10 is already done, plus 1 in its outermost shell. So yes, you have 11 electrons. So it is okay. One more thing. You said it has 11 electrons like this. So why do you say this is its atomic number? So what is the atomic number of an element?
Number of protons in nucleus.
Okay, but you have just found the number of electrons.
Hmm.
So why do you say this is equal to the number of protons?
Because atoms is neutral, so number of
Exactly.
electrons is equal to
Right.
number of protons.
Excellent. Right. Yes. So because this is an uncharged or neutral atom, right? Therefore, the number of the number of electrons equal to number of protons. So that is equal to 11. That is its atomic number. So the correct answer is C. Okay, so my next problem is, hmm, okay, is there any way in which I can send you guys the PDF of the questions? Is there any such um, facility in Google Meet? In message chat, I think I can only type something but not send the PDF. Okay, no problem. So we have an electric field E, which is acts between a pair of parallel plates, okay, as shown. So you have something like this. Okay, this is positive, and the lower one is negative. So this is L, the length of the upper plate. Okay, so you have a charge Q. This enters the space between the two parallel plates. So you have a charge, entering here. So this is Q. Okay, within the two parallel plates, written till that, with initial velocity v, perpendicular to the field direction. Okay, so find the vertical displacement of the charge inside the plate. Okay, so did you understand what it means? So, like, did is the meaning of this problem clear to you? So you have an electric field that is acting between the pair of parallel plates, and you have a charge entering this. So what is the vertical displacement of charge inside the plate? So can you try solving this problem? I mean, please try and let me know. Okay, yesterday sir has solved this question. Okay, so what have you understood from that? Like, can the one who's written Jemima, can you tell me what is like, can you just explain it in 1 minute? Okay, since this has already been done, I'll just explain it in short. That, if it enters, if the polarity is such as given in the picture, so you know that the electric field will be in this direction. This is E. So you have the charge entering like this and all. So the force acting is equal to QE, right? So from here you'll get the acceleration. Acceleration is equal to force by mass, right? So QE by M. Okay. And so the time taken will be L by V, whatever is V. So you have the vertical displacement, this one, Y, that is equal to half AT square. So you put in the values and what do you get? I think it is QE L square by 2mv square. Okay, so in this, what is the vertical component of velocity at the moment? Has this part been done too? Somebody please write in the chat. What is the vertical component of velocity? This is the displacement, right? So now what is the velocity? What? Why is it zero? The velocity will not be zero. You guys have understood till this part, right? I didn't go too much of explanation because you already said this been done. So if you understand till this part, you will know that the velocity will not be zero. Why is that? Velocity will be dy by dt. Okay. It's not always dy by dt. You also have some, it is dy by dt when you already have an acceleration here, right? Isn't that? Okay. So the what the question is saying is, what is the velocity at, this point, at here? What is the, you can say in red, when it has already left, the plates. So it already has an initial acceleration due to the electric field which is acting on it. Okay, so the velocity over here. So what is the answer? Okay, is that L? Yes, right. QEL by MV, right. Somebody velocity, vertical component of the velocity is zero. No, this will not be zero. Okay, at this point, at the marked point. Okay, I'm writing this like this. So, I'm talking about this part. So here you see the velocity, acceleration into time. And so what is the acceleration? And what is the time? So acceleration is, the force by mass. So QE by M, and time is L by V. Okay. So this is as is already, as somebody has already said, this is the answer. This is the velocity when the this particle leaves the plate, this charge. Does anybody have a doubt here? So this is just the velocity the moment it leaves the plate. Okay, so next we will solve another problem. This is on Millikan's oil drop experiment, where what did he say in this experiment? He just said that, like, he discovered that the oil drops, they have some charge on them, right? And they are just multiples of this value of Q, the fundamental unit of charge. Okay, so based on that, let us solve this problem. You have a tiny spherical oil drop carrying a net charge Q, balanced in still air with a vertical electric field. Okay, this is uniform also. Electric field E, which is equal to 80 into 10 raised to the power 4 V per M. So when the field is switched off, The drop is observed to fall with a terminal velocity say Vt, that is equal to 2 into 10 raised to the power minus 3 m per second. So given g is equal to 9.8 meter per second square and the is viscosity of air is 1.8 into 10 raised to the power minus 5 Newton second per meter square, and density of oil is 800 kg per meter cube. So the magnitude of Q is approximately 80 into 10 raised to the power minus 19 coulomb, or 32 into 10 raised to the power minus 19 coulomb, or 16 into 10 raised to the power minus 18 coulomb, or D 3.8 into 10 raised to the power minus 19 coulomb. So can you tell me, or can you guess how to do this? Let me know once you're done. In just a minute, I'll be back. In just a minute, I'll be back. Okay, so no answer. Did anybody try to solve it? Okay, so here you see you have can everyone hear me? Please confirm me that first. Can you hear me? Okay, thank you. So here you see you have a tiny spherical oil drop and it carries a net charge of balanced it and it's balanced in still air with a vertical uniform electric field of 18 to 10 raised to the power 4, right? Okay, so when this field is switched off, it is observed to fall with a terminal velocity of something. So you have to find the magnitude of Q. So you know that when this drop is balanced in air using Stokes theorem, you get, like, suppose this is the electric field. This is okay. This, and you have an electric field acting in this direction, right? So um, say this is E, and you have your charge over here. So in balanced condition, you have this QE, which is acting in this direction. This is QE, and it has already achieved a terminal velocity, okay, which is in this direction, mg, right? Now using Stokes theorem and all, you have this condition QE is equal to 4 by 3 pi r cube, okay, rho into g. What is rho? This is just the density of this oil, okay? This is when it is balanced in air, and when it has achieved a terminal velocity. Then this is equal to whatever it has achieved, okay? So 4 by 3 pi r cube rho g, that is equal to 6 pi r eta v. This comes from Stokes theorem, where say this is the terminal velocity vt. So if this is my equation 1 and this is my equation 2, then from 1 what do I have? So from this we have r cube is equal to 3qe by 4 pi rho g. Is that okay? Yeah. So from here you will get r is equal to 3qe by 4 pi rho g, 1/3 of, raised to the power 1/3. So let this be my equation number 3. And from equation 2, what do we get? From 2. From here, you cancel out R. 1 R goes out. So R is equal to 9 eta Vt by 2 rho g. This is raised to the power half. Okay, so this is my number 4. Okay, so now you combine 3 and 4 to get. So just equate 3 and 4, and what do you get? Let me know. This is Q is equal to 4 pi rho G by 3e multiplied by 9 eta Vt divided by 2 rho G. This raised to the power 3 by 2. So please put in the values and let me know how much you get. Which option do you think is the correct one out of these? Let me know. So you put in the values. So you have 4 pi 3.14 and rho 800 kg per meter cube. This is 800 into the 9.8 by 3 into e is 18 to 10 raised to the power 4. Okay, this into 1.8 into 10 raised to the power minus 5 into 2 10 raised to the power minus 3. This you have 2 into 800 into again 9.8. This all raised to the power 3 by 2, and you get something around 38.5 into 10 raised to the power minus 19 coulomb. So this means 3.5. Oh, sorry, I gave a wrong. This is 38.5. So the answer is D. Okay. So the answer to this particular problem is D. Okay, now we'll go to the next problem, which is the amount of electricity that can deposit 1.08 grams of silver from AgNO3 solution is 0.15 coulomb. Second option is 1 coulomb. Third option is 0.01 Faraday. And the last one is 0.01 coulomb. So which one do you think? I mean, what will this be? Can you please try it out? Are you solving it? Can anybody tell me what is the equivalent weight of a substance?
Atomic weight divided by valency.
Okay, why do we take the valency?
Sorry, ma'am.
Like, why do we
What is
take
the
the
question?
valency? Like, why are we interested in the valency of the atom, not the atomic number?
Mm,
Okay, let me write it down for you. You see, the equivalent weight of any substance. That is, you can say equivalent weight of a substance is equal to the ratio of the atomic mass of your element, of your metal, of your it's better to write of the element, and the number of electrons required for reduction of the cation. So you see, only the electrons which are free, that means the valence electrons in the outermost shell, which can leave the atom, only they can take part in the chemical reactions, right? So that is why we take the valency of the element and not the atomic number and all, because the others are tightly bound to the core of the element. Okay, so this is just a concept in case it wasn't clear to you. So yes, are you trying to solve this problem? So what is the amount of electricity that can deposit 1.08 gram of silver from silver nitrate solution?
is it option D, 0.01 coulomb?
Yes, you're right. How did you solve it?
M varies to Q. So M equal to EQ. M here is 1.08 and
Hmm.
equivalent weight of silver is 1.08 nearly, 108. So
108 gram.
108. So
Hmm.
Q equal to 1.08 divided by 108. So it is
Okay.
0.01.
Okay, excellent. Okay, so the gram, so the solution is the gram equivalent weight of silver is around, again we'll take the atomic, it's around 108 by the valency over here, which is 1, so that is 108 grams only. So you know that 1 Faraday of electricity is, required for depositing 1 gram equivalent weight of an element. So 1 Faraday you need for here 108. This is the equivalent weight, right? So let us just reverse this. This is 1.08. So 100 grams. This requires 1 Faraday. Therefore, how much will 1.08 grams require? 1 by 108 into 1.08. That is approximately, yeah, 0.01 coulomb. Right, so option D. Okay, so once again, let us solve another similar kind of problem. I think this is number 5. Okay, a current of 0.5 ampere is passed through NaCl solution. Therefore, the time required to liberate 0.5 moles. So, what is the time required to liberate 0.5 moles of H2 gas at the cathode? So, let me know. Shall we start discussing the answer? What are you thinking of? I mean, how do you plan to approach this problem?
Force equal to Q into E,
Okay,
downward
force
direction.
force is equal to Q into E. You mean if I have the particle like this, there will be a force acting in this direction?
Yes.
Okay. Mm-hmm.
Then velocity. Yeah, we have to first measure the velocity along the horizontal component and vertical component. Vertical
Okay.
component is if Vy means upward direction is y direction. So
Okay.
Vy equal to speed 20. So 20 um, sine
20.
upward sine 20 no 20 angle sine 45.
Okay, you mean
Mm,
20 into sine 45 degrees.
45 degree.
This?
Yes.
Okay.
Equal to 20 by root 2 meter per second.
Hmm.
Okay, then force in a region without gravity. So there is no gravity,
No mg term.
OMG term.
Hmm. Hmm.
We have to balance the condition means downward force and upward.
Okay, what will be the upward force?
Upward force M into A.
Okay, m into a, that is equal to q into e.
Yes. We have to solve means we have to measure A.
You have to
A
measure.
equal
Okay, so a, yes, you are going absolutely in the right direction.
Q
Yes.
into E by M.
Mm-hmm.
Then find A equals to Q equal to 10 to the power minus 4 coulomb and E equals to 10 to the power 10 volt per meter and M equal to 1 gram. So I convert M in kilogram. So it obtain that I 10 to the power minus 4 into 10 divided by kilogram to 10 to the power minus 4, 10 meter per second. Is it?
Okay.
Mm,
Yes, 10 meter per second. Correct. So here you get the acceleration, and then
then height s equal to ut plus half at square. If
okay, plus half at square.
mm, u equals to 20 by root 2. I have to measure t.
Hmm.
Mm. Final v at the maximum height v equals to 0.
Yes, right, right. Yes, equal to. Okay, wait, let me write it nicely for the others.
Mm.
Yes, so what will be the maximum height,
Half at
right?
square.
Hmm.
Yes. Then v equals to
But what is
u.
t?
Hmm. And another equation v equal to u plus 80. So v is equal to 0. Then initial velocity u equal to 20 root 2. Hmm.
Can I write a formula like this? Is equal to say mm, v square
Yeah, equal to
sine
u square
square
theta.
theta pi to a.
Hmm. Yes.
Can I write this?
Ha, 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 ha. Yes, yes, yes.
Right? So what will I get?
V square
What was my u? 20. So
20
I will not be using this here. Just use v square
sine
sine
square
square
theta.
this. Okay, this is 20 square sine square 45 degrees
For the degree.
by 2 into 10. What is it? Please tell me. Let me also calculate. Yes, so what are you getting?
10, 10. 10, 10, 10.
Yes, 10 meters. Yes. So is that okay with the others? This is the answer. Excellent try, Ananya. Keep it up.
Thank you, ma'am.
Okay, so if this is okay with the others and they don't have any other confusion about this, so the second part that the second part of this problem, find the time required for the particle to return back to the line AB after it is thrown from A. So it has already attained, the maximum height. So now how much will it take? The total time for it to reach the baseline. I didn't draw B, I didn't mark which is B, say this is my B. Okay? This point.
Is it 2 root 2 second?
2 root 2 second. Okay. How do you get it?
V equal to U plus AT. So V at maximum height U equals to 0. So T equal to U by A.
No, 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 no. Here you are saying that from maximum height, right? Like the time taken by the charged particle to reach from that height to the baseline. You're not talking about that. Okay? See, the question says find the time required for by the particle to return back to the line AB after it is thrown from A. So after it is thrown from here,
Yeah, okay.
okay, you get it? Not
Mm-hmm.
not from here. No, from here.
Oh, okay.
Okay, let me drop a hint. Okay, so uh, you know there is something called time of flight, right? For projectile motions, as you can see that this is definitely a projectile motion problem, right? So can you use, I mean, there can be other ways to solve, there can be millions of ways to solve a problem. That's okay. But this is also another way. So can you use any equation related to time of flight. Basically, in a projectile motion, when you throw something like this and it's a projectile, okay, this has a trajectory, the time it takes to reach the baseline, this time, that is called the time of flight. So basically, the question is asking for this time of flight. So you just put in the equation which gives you the time of flight, and you get it. Okay. So this time of flight t, that is given by 2v sine theta by acceleration. Now tell.
Two into v equals to 20 sine theta. 2v, 2 into 10
Hmm.
into sine theta, sine 45
Hmm.
divided by 10.
Huh. So what did you get? Must be around
10, 10
2.8.
cancels out. 2 into 1 by root 2.
Hmm.
It's root 2.
According to me, it comes out to be this second. Okay. So that is how you solve problems like this. Is this clear? If there is any doubt, please ask me. That is why I am here. Okay? If not, I'll go to the next problem. It's quite simple. Okay, it was number 6. So number 7. So again, in Millikan's experiment, okay, you have a negatively. If you don't understand my handwriting, please let me know. Charged oil drop of mass 3 into 10 raised to the power minus 14 kgs is balanced by applying a potential difference of 10 kV between the plates which are 30 mm apart. So you find the charge on the oil drop. Yes, so please solve it quickly and let me know. Anyone done it? Somebody has said something? 9 into 10 raised to the power minus 19. Okay, let's solve this. Somebody has given this answer. Thomas has given this answer. Is it JJ Thomas? Okay, so this is pretty straightforward, right? In this oil drop experiment, if you have your plates and you have your electric field like this, you have an oil drop falling downwards, mg weight, and your electric field acting upwards, right? So it's just you equate these. So QE is equal to mg. So let us put in the values. Yes, Ananya, you want to say something?
equal to V by D. So formula is Q equal to
Hmm.
mg by Vd.
Yes,
mg
yes,
d
yes.
by V.
Right, right, right. Yes. D by V. Yes, absolutely. So you have your mass of 3 into 10 raised to the power 4 minus 14.
14,
G, how much did you take, Thomas?
10,
Okay, 10.
10. Um,
Okay, let us go with 10. D is 30 millimeter.
meter. Convert into
Hmm.
meter, 30 into 10 to the power minus 4 mm, meter.
4. Is it 4 or
Meter.
3?
3. Oh, meter. 3, 3, 3. Sorry.
Right, right, right. Yes. And this is 10 kilovolt. So,
10 into 10 to the power 3.
so how much does it come out?
Mm, 10, 10, 9 into
So this
3,
is
3, 6, 10,
minus
9.
6, right?
Yes, 6 and 14, 20. And
So
1, 10, 10
90.
to the power 19. 9 into 10 to the power minus 19.
Yes, absolutely. Thomas, you're correct. Okay, so now we don't have much time, so I'll just be, asking you a few very basic questions just to check if you are like, if these concepts are okay with you. So, uh, I'll write a few models, just pay attention. Say from this is number 8, and out of the Bohr's model, then Rutherford's model, then Thomson's model, and say none of these. Which model is unable to explain the stability of an atom? Which model out of these is not able to explain the stability of atoms? Rutherford model. Yes, right. Okay, the next one, we just go quickly. If you are unable to, relate or understand, let me know. Okay. So out of nucleus, proton, and then neutrons, and then electrons. Which of these was discovered by J. Thomson cathode ray experiment?
Electron.
Neutron.
Yes, right. Okay. Okay, I think for the first time I heard somebody else speaking. Please keep it up. Okay, out of the radius of electron orbit and shape of orbit and spin of an electron and the size of a nucleus, out of these, the principal quantum number n describes which of these?
Radius of.
Radius.
Radius of an electron orbit, are you sure?
Yes.
Yes.
Absolutely. Right. Okay. Out of the atomic radius, the atomic number, the atomic weight, and the equivalent weight. Which of these is always a whole number?
Atomic number.
Are you sure?
Yes.
Absolutely correct. Okay. And the last one, okay, time is almost up. Let's look for a good one. Okay, suppose you have a few sentences that every substance is made up of extremely small particles known as atoms. And your second sentence is that atoms are not the ultimate matter particles. And your third statement is atoms cannot be destroyed. And the last statement is different elements have different chemical properties. Okay, so these are my sentences. So you tell me that according to Dalton's atomic theory, which is the wrong statement?
Option B.
Exactly correct. Okay, so yes, I think according to your first lecture, these are the kind of problems which are possible from there. And I'm extremely sorry for the technical glitches at the beginning of this. As you've seen that at the end, it was smooth, I guess. And if you feel that you are, you have some, like you're unable or you want me to share the PDF or something, just let me know. Any problem with my sessions, please let me know. You want me to have maybe tougher problems, let me know that. So thank you for attending this session. This session we'll again meet next Saturday, same time. Bye bye.